Hi guys, today we're going to be talking about systems of equations and inequalities with word problems. So just a reminder, systems of equations are when you have multiple equations and you're kind of finding their intersection or where they're the same or where they're equal. So that means we're going to have more than one equation to write. And typically, in all the examples we're going to see, while systems can have more than two equations, most of them we're going to see two equations that we have to write. Example one, you sell tickets for admission to your school play and collect a total of $104. Admissions are $6 for adults and $4 for children. You sold a total amount of tickets of 21. And how many adult tickets and how many children's tickets did you sell? So we need to make sure we're writing two equations. So we're going to have to group some of the information into two groups. And then we're also going to have to define our variables. Defining our variables is something really important that we need to do for all of our word problems. What can be really helpful for defining our variables is reading the last question, because the last question tells us what we need to find, and generally we have to solve for these variables. So we need to find how many adult tickets and how many children's tickets. So we're going to have two variables. You can name them whatever you want. I'm going to say A for the number of adult tickets. And then I'm going to say C for the number of children's tickets. And again, I got that right there from the question that they asked to help me define my variables. Now I need to write two equations and I need to group my information. So I'm going to reread the prompt. So we sell tickets for admission to your school play and collect $104. Admission are $6 for adults and $4 for children, and you sold 21 tickets. So when I read this, I immediately think, oh, I've got stuff to do with money, and then I have something to do with the amount of tickets. I'm going to group all of the money together to help me make my first equation. So my first equation is, I'm going to have a total of, it's going to be equal to $104 because that's my total. And it tells me the cost for adults is $6. So for every adult, I have to pay $6. So to find that total amount of money, I have to do 6 times the number of the adults. And then I'm going to add the cost for the children's tickets, which is $4 for each child. So this is my first equation. 6a plus 4c is 104. And that's kind of my money equation. Then I have this other piece of information that says I sold 21 tickets. So I'm going to have a total of 21, but what's made up of those tickets? Well, what's made up of those tickets is a certain amount of adult tickets and a certain amount of child tickets. So it's just A plus C. And there I have my two equations. Now we need to solve this system of equations. And we have three methods to do this that we learned in our last module. We have solving by graphing. We have our substitution method. And we have our elimination method. While we could do any of these to help us, I think in this situation, I'm going to specifically choose the substitution route. And the reason I like substitution in this route is because I already have A and C by themselves almost. So it's very easy to solve for one and then put it into the other equation. Elimination is also a good option. Graphing, I could absolutely do, but I think I prefer the algebraic methods for these word problems. So then I don't have to make a whole graph, label the axes, and that can get a little bit confusing sometimes. So let's use substitution. So I want to get one of these variables by themselves. It doesn't matter which one. I'm going to rewrite the equation. And again, I chose this one because these are basically almost already by themselves. And I'm just going to get the a by itself. Doesn't matter which one you choose. Either way works. So I'm going to subtract c from both sides. And I get a is equal to 21 minus c. And now that I know what this a value is, I can take it and take that whole chunk and put it in for the a value in the other equation, rewrite the equation, and then I'm only going to have c's, which then I can solve for. So what this will look like is I'm going to have 6 times 21 minus c, the whole thing goes in for a, plus 4c is equal to 104. And then I can solve this to get the c by itself. So I'm going to distribute. So when I distribute here, I get 6 times 21, which is 126. If you need to use your calculator, please make sure you do so. And then we'll get 6 times negative c, which is negative 6c. Bring down the 4c and the 104. Then I can combine like terms. These are like terms, so I can combine them. So I bring down the 126. I add these together. I get negative 6c plus 4c, which is negative 2c, which is equal to 104. Now I want to get the c by itself, so I got to get rid of this 126, so I'll subtract that from both sides. And again, if you're having trouble with the subtraction, you can use your calculator to help you. I'll bring down the negative 2c. Those go away. And then the difference here is going to be 22. And then I just need to finish up solving this. Oops, excuse me, that's a negative 22. And then I'll get negative 2c is equal to negative 22. I'll just rewrite it, divide both sides by negative 2, and I get that c is equal to 11. And then from there, we're going to take that 11 and use it to help us find our a. And I'm going to take it here, put it in for c in this equation. It doesn't matter which equation you choose to put it back into, but I think this equation is simpler, so I'm going to choose that one. So I'll take that c and I'll put it in. So it'll be a plus 11 is equal to 21. And then I have to get the a by itself, so I subtract 11 on both sides. So a is equal to, those go away, and I'm just left with 10. So now I found my c and a value. I'm going to rewrite it as a sentence to put everything back together. So this c is equal to 11. That really means the number of children's tickets. So let's see. They sold, or you sold, or I guess I sold 11 child tickets. And then this is the number of adult tickets and 10 adult tickets. And that's the total amount that you sold, and there is the end of that problem. Example 2. Casey orders 3 pizzas and 2 orders of breadsticks for a total of $29.50. Rachel orders 2 pizzas and 3 orders of breadsticks for a total of $23. And then it asks, how much does the pizza cost? So again, we're going to have to write 2 equations here. But first, as we did in the previous problem, we're going to start by defining our variables. And we're going to define our variables by reading this last question to help us. So it says, how much does a pizza cost? So we will have a variable, and I'm going to call it P for pizza. And it's going to be the cost of a pizza. But usually we have 2 variables, and this question only refers to 1. Well, it also, we kind of have to think about, well, what else do we not know? We don't know the total cost of the breadsticks. So I'm going to make another variable, and I'm going to say B for breadsticks, and that's going to be the cost of an order of breadsticks. Then we need to write our 2 equations, and we need to group the information from this prompt. So in our last problem, we had an equation with money, and then we had an equation with the total number of tickets. Here, if I think about the information that I have, I've got stuff dealing with money twice, and I've got stuff dealing with the amount as well. But I don't see a way I can just group it by the amount and the cost. But I do see a break by the person. I can see a specific situation dealing with Casey. Casey ordered 3 pizzas and 2 orders of breadsticks for a total of $29. So our total's $29.50. And she bought 3 pizzas, and that's additional to the 2 orders of breadsticks to give us your total. So we have a break here in a group that deals with Casey. Then we have a group that we can do with Rachel. She ordered 2 pizzas and 3 orders of breadsticks. So we'll add those together. And that equals the total of $23. So here, our split of the information dealt with the people and their specific how much they bought. Now we need to solve this system. We have our 3 options: graphing, substitution, or elimination. Looking at the equation, if we use substitution, I think we're going to get some fractions and it might get a little bit messy, which is fine and we can totally deal with because we have a calculator we're allowed to use. But for this problem, I want you guys to try using elimination. And I want you guys to try this on your own, and then I'll reveal the answer in a second. So pause the video here and try elimination to solve this problem. Okay, so using elimination, I decided to eliminate the P. So I needed these to be the same, well, not the same, but opposite signs. So I made this into a -6 by multiplying the entire thing by -2. So that also changed the B or the 2B and the $29.50. And then here I needed this to be a +6. So I multiplied this by a +3 and I did it to the whole equation. So this became a 9B and this became a 69. And from there, I eliminated the P and combined both equations. So with the B's, -4B plus 9B is 5B. -59 plus 69 is 10. Divide both sides by 5 to get the B by itself, so B is 2. So that means our cost of a breadstick is $2. And I'm going to take this and put it back into one of the equations. Doesn't matter which one, I just chose the second one. Put it back in, substituted it in for B, solved the equation, and I got that P was equal to 8.5. That really means a pizza costs $8.50, which answers the question, how much does a pizza cost?